Hi thinkers, welcome to Math Thinker. In the previous videos, we have already finished two chapters, that is number system and LCM and HCF. So today I am starting a new chapter, that is decimal fractions. Decimals are the foundation of percentages, profit and loss, simple interest, time, speed, distance and data interpretation. If your decimal concepts are weak, calculation in exams will take double time. So today we will master decimal fractions with both clarity and exam shortcuts. So in this chapter we are going to learn definition of decimal fractions, conversion of fraction into decimal and decimal into fraction, important points, operations with decimals, comparison of fractions, and at last we are going to learn recurring decimal. So first of all, let us see what is decimal fractions. A decimal fraction is simply a fraction whose denominator is 10, 100, 1000, etc. Means the denominator is the power of 10. Let's see one example. Let's take a fraction 3 by 10. So how can we write this in decimal form means? So first write the numerator 3 and see the denominator. How many zeros are there? After that many digits, you should keep the decimal point. Means here only one zero is there. So after only one digit, keep the decimal point and keep 0. So 0.3 is the decimal fraction. Let's take another example. 27 by 100. So now write 27 as it is and see how many zeros are there? 2. So after 2 digits, keep the decimal point. So 0.27 is the decimal fraction. Let's take another example. 456 divided by 100. See, now write the number as it is and see how many zeros are there. Again 2. So after 2 digits, 1, 2. Keep the decimal point. It will be 4.56 is the decimal fraction. So next we are going to learn conversion. In that first we are going to learn fraction to decimal conversion. So first what we have to do means we should adjust the denominator to 10, 100 or 1000. Means to the power of 10. Let us understand it with one example. I will take a 7 by 20 and 100 is a multiple of 20. So let us make this denominator to 100 by multiplying with 5. It will become 35 by 100 and we can write it as 0.35. So we have converted it into decimal. Let us take another example, 1 by 125. So 1000 is a multiple of 125. So we can make it to 1000. So by multiplying it into 8, we can convert the denominator into 1000. So 8 by 1000. First write the numerator and count how many zeros are there? 3. So after 3 digits, here only one digit is there. You can add as many zeros as the denominator zeros. Means you can add 2 zeros as it will be 3 digits and you can keep the decimal point. So the decimal is 0.008. Now let us learn how to convert decimal to fraction. So first what we have to do? Remove the decimal, divide by power of 10 and simplify. Let us understand with one example. 0.48. First remove this decimal point and write it in the numerator. 48. Divide it by power of 10 means keep as many zeros as the digits after the decimal point. Means see here 2 digits are there after decimal point. You can keep 2 zeros, 100. And now simplify. 4 ones are 4 twos are 4 twos are 5. So 12 by 25 is the fraction. Let us take another example. 0.25. Write it 25 in the numerator and again see how many digits are there after decimal? 2. Write 2 zeros and it will be 100 and you can simplify. 1s are 4s are, so 1 by 4 is the fraction. Now we will see some important points regarding decimal fractions. See first one. Zeros to the extreme right of a decimal fraction does not change its value. See the example 0.8 is there. I can write it as 0.80 also. I can even write it as 0.800 or even 8000. so on. So even though I add so many zeros at the extreme right of a decimal fraction, it does not change the value. It will be 0.8 only. See another example. If it is 0.0067, for these zeros it has a value, means if you add 0.00067, the value will change. But if you write 0.0067 again 000, the value is same. Both are equal, but these are not equal. See the second point. If numerator and denominator of a fraction contain the same number of decimal places, then we remove the decimal point. Means if it is a 1.84 divided by 2.89, means both the decimal points are after the 2 digits. So we can write it as 184 and 289 by cancelling the decimal points. See why we can write it like this, means if it is 1.84 and 2.89, if you multiply 100, then this decimal go away from the 2 decimal places, means it will become 184.0, which is 184 only, and this also goes away after 2 digits because here we have 2 zeros. So it will be 289.0, means 289. So without doing like this, directly we can write by cancelling the decimal points. See if it is 3.849 and 4.144, we can directly write it as 3494144. Okay, next we will see operations with decimal. So first is addition and subtraction. The numbers are placed such that the decimal points lie in one column and now be added or subtracted in a usual way. Let us see one example. 5.67 is added to 2.30. See what it says. The numbers are placed in such that the decimal points lie in the same column. Means see the decimal points are in the same column. Now add in a usual way. 7 plus 0 is 7. 9.7. 7.97 is the answer. So whatever numbers are there, the decimal point should be aligned in the same column. In the same way you can subtract also. So next we will see multiplication. In multiplication, first multiply the numbers as a whole numbers, and after that place the decimal according to the total decimal digits. Let us see one example. 2.5 into 1.2. You can do it as 25 into 12, means we have to multiply as the whole numbers. 12 5 is a 60, 12 5 2 is a 24, 24 plus 6 is a 30. Now answer is 300. After that you can keep the decimal point. First we have to count the decimal digits, means here one digit is there, here also one digit is there. 1 plus 1 means 2. So after 2 digits we should keep the decimal point, means here it will be 3.00, means 3 only. Okay, multiplication case, what we have to do? First we have to multiply them as a whole numbers. After that you count how many digits are there after the decimal and keep the decimal point according to the total decimal digits. Next we will see division. Dividing a decimal fraction by a counting number, means by a whole number. Divide the given number without considering the decimal point by the given counting number. Now in the quotient put the decimal point to give as many places of decimal as there are in the dividend. So you will understand this with one example. Let's take a 0.0204 dividing with a counting number, means whole number I will take 17. Now first divide it without considering the decimal point, means 204 divided by 17. So when you divide this you will get a quotient as 12. Now in the quotient put the decimal point to give as many places of decimal as there are in the dividend. See how many digits are there after the decimal point? 4. Now you should make it 4 digits and keep the decimal point. Means you add 2 zeros, it will be 4 digits and keep the decimal point. So 0.0012 is the answer. So how we have done in the multiplication, first we multiplied and then we kept the decimal point. In the same way, divide as a whole number and after that you can count the digits and keep the decimal place. Now we will see in the second case, means dividing a decimal fraction by a decimal fraction again. In that case, multiply both the dividend and divisor by a suitable power of 10 to make the divisor a whole number. Now proceed as above. You can see here, let us take one example. 0.00066 divided by 0.11. So first you should make it as a whole number. Means you can multiply 100 to make it as a whole number. It will be, the decimal place will shift to after 2 digits, as here 2 zeros are there. So it is 0.066 divided by 11. Now we can do it as above. So it is 66 by 11. The answer is 6. Now see, after how many digits the decimal place is there? After 3 digits. So keep 00.0. Means after 3 digits the decimal point should be there. So answer is 0.006. So in the division, if it is a whole number, directly you can divide as a whole number and after division you can keep the decimal point. See, if the denominator is also a decimal fraction, then you have to make it a whole number and then proceed as above. Okay, now let us see comparison of fractions. Suppose some fractions are to be arranged in ascending or descending order of magnitude, then convert each one of the given fractions in the decimal form and arrange them accordingly. Suppose we have to arrange the fractions 3 by 5, 6 by 7 and 7 by 9 in descending order. You know another method, we will take the LCM and we will proceed. But the easier method is we can convert these into decimals and we will get the answer soon. You can see 3 by 5 is a 0.6. How we got 0.6 means it is 3, it is 5. As 3 is smaller than 5, we should take a decimal point and we can keep the 0. So 5, 6, it is 30 and we'll get the remainder as 0. So 0.6 is the decimal of this 3 by 5 fraction. So 6 by 7 means 0.857 and 7 by 9 means 0.777. Like this it will go on. So now see, after the decimal point, which is a greater? Here it is 0.6, here it is 0.8, here it is 0.7. Means 8 is a greater. So first write it as it is a descending order, 0.857, after that 0.777, after that 0.6. Means in the fractions it is 6 by 7, 7 by 9, 3 by 5. It is the descending order. So 6 by 7 is greater than 7 by 9 is greater than 3 by 5. So without taking the LCM, directly we can do the ascending or descending order in a decimal form. So lastly we will see recurring decimal. See, what is recurring decimal? Means if in a decimal fraction a figure or a set of figures is repeated continuously, then such a number is called a recurring decimal. See in the above example, this one, 7 by 9 equal to 0.777. Here 7 is repeating so many times. This is a recurring decimal. Let's take that example only, 0.7777. We can write it as 0.7 and above that 7 dot. Means it is repeating. Let us take another example, 1 by 3. this we will get decimal as 0.3333 like this, so on. So we can write it as 0.3. Above that 3 we can keep a dot, means 3 is repeating, so it is a recurring decimal. If so many numbers are repeating, see the pi value 22 by 7 equal to, it is 3.142857. Again it is 142857. So this is repeating again. So we can write it as 3.142857 and above that write one bar. Means it says that these numbers are repeating again. See, pure recurring decimal means a decimal fraction in which all the figures after the decimal point are repeated is called a pure recurring decimal. Means see here 0.333 is there, no, it is a pure recurring decimal. And if it is 0.535353, this is also pure recurring decimal. We can write it as 0.53 above that bar. Let us see how to convert a pure recurring decimal into fraction. So first what we have to do, write the repeated figures only once in the numerator and take as many as 9s in the denominator as the number of repeating figures. Let us take this example only, 0.53 above that bar. Now you should convert this into fraction. First write the repeating figures in the numerator. So write 53 in the numerator and take as many as 9s in the denominator as the number of repeating figures. See how many digits are repeating after the decimal point? 535353, like this it is repeating, means only 2 digits are repeating. So take 2 9s in the denominator. So this is the fraction form. Now take another example, 0.067 above that bar. This is a pure recurring decimal. We have to convert this into fraction. First write the number in the numerator 67 and in the denominator see how many digits are repeating after the decimal. 1 2 3 digits are repeating, so keep 3 9s in the denominator, so it's a fraction. Like this we can convert a pure recurring decimal into a fraction. Now let us see what is mixed recurring decimal. A decimal fraction in which some figures do not repeat and some of them are repeated is called a mixed recurring decimal. Means some of the digits will not repeat but some of the digits will repeat. For example, 0.173333 and so on. So in that time what we have to do, we can write it as 0.173 and above 3 you can keep a bar or a point. Means it means that 3 is repeating many times. So this is a mixed recurring decimal. Now let us see how to convert mixed recurring decimal into a fraction. First we have to subtract non-repeating part from the whole decimal part for the numerator, and in the denominator write as many 9s as repeating digits followed by as many zeros as non-repeating digits. Let us take same example, 0.173 and above this bar. So first what we have to do, subtract non-repeating part from the whole decimal part. First we have to write the whole decimal point. This is 173 in the numerator, and subtract non-repeating part. Which is non-repeating? 17 is a non-repeating. You should subtract 17, and in the denominator you should write as many 9s as repeating digits followed by as many zeros as non-repeating digits. It is as, okay. So how many digits are repeating? Only one digit is repeating, so only write 1 9 and write zeros as and write as many zeros as non-repeating digits. Means only 2 digits are non-repeating, so write only 2 zeros. So the answer is 156 by 900. It is the fraction. Let us take another example, 0.16. Above that 6, 1 dot means 6 is repeating. So first write the whole decimal part 16 minus which is non-repeating 1. So write 1, subtract it, and in the denominator write only 19 because only one digit is repeating, and only 10 as because only one digit is non-repeating. So it is 15 by 90. This is a fraction. So till now we have covered definition, conversion, important points, operations with decimals, comparison of fractions, and recurring decimal. So these are all the concepts of decimal fractions, and in the next part I am going to deal with the basic questions on decimal fractions. So if you are thorough with these all what I have explained till now, then it will be very easy to solve the basic, intermediate and advanced questions on decimal fractions. So till the next video, practice these all. Thank you for watching and subscribe for learning maths in a unique way. Bye Maths Thinker.